So, the NeXTstation is alive, it boots straight to the desktop and then immediately refuses to believe that we're living in the year 2025.
Is it year 2000 safe?
Of course not, it needs a patch, but fear not, in today's deep dive into Nextstep, I've got you covered. Retrocomputing is the use of older computer hardware and software in modern times. I'm the Vintage Collector and these are my stories. I didn't explicitly mention it in the previous video, but the release I chose to install on the NeXTstation is Nextstep 3.3. Version 3.3 is generally considered the best choice for Motorola-based machines. While these systems are technically supported by the newer OpenStep 4.x, performance and compatibility often makes 3.3 the safer bet. After Apple acquired Next in 1996, there was obviously still enough demand from legacy users that Apple released official Y2K patches, not just for OpenStep 4.2 but also for Nextstep 3.3, which originally came out in 1995. Apple made these patches available for free and even offered free copies of Nextstep 3.3 to registered users running older versions, essentially providing a proper upgrade path for black hardware owners. The patch set includes updates for the base system, covering both RISC and CISC CPU architectures, as well as fixes for the developer tools. Since the Motorola 68040 is a CISC processor, I'll go ahead and apply the CISC patch set. While the patch installer does its thing, it's worth pausing on one small detail, the package format. Nextstep introduced the PKG bundle as a way to package software cleanly, complete with versioning, metadata and install scripts. And yes, that same format still exists on macOS today. Even though most application software today comes wrapped in a DMG image file or is directly installable from the App Store, .pkg files are still in use as well. So what we're looking at here is more than a period correct installer, it's the ancestor of something still alive and well in modern macOS. After a quick reboot, we're back on the desktop. Finally, I can set the system date to 2025 without the control panel just silently reverting to 1995. Now, I could walk you through Nextstep and give you an exhaustive comparison of what's still around in macOS today. But that has been done plenty of times already, like this one, a 10-year-old breakdown. Many familiar elements are still here, just with a facelift, new features and a lot more polish. And I think it's fair to assume you already believe me when I say macOS is a direct descendant of Nextstep. But that still leaves one question. What exactly is Nextstep? Nextstep is a Unix derivative based on BSD 4.3, part of a distinct development tree that originated from AT&T's Unix version 6 and was later developed independently at the University of California, Berkeley. For years, Nextstep and BSD evolved on their own path. Eventually, BSD became the base for various open source derivatives like NetBSD, OpenBSD and FreeBSD once all copyrighted AT&T code had been stripped out. Now you know why I took the time to explore running NetBSD on a Macintosh in a previous episode. It's all connected. Because as Nextstep evolved into OpenStep 4 and later into Rhapsody, essentially OpenStep 5, parts of NetBSD were gradually incorporated into the system. And the same thing happened again with Darwin, the core of OS X and macOS, which pulled in substantial components from FreeBSD. Compared to the typical Unix systems of its time, Nextstep did a lot of things differently. It used display PostScript instead of X11. And while Unix traditionally fumbled around with C and C++, Nextstep offered a fully object-oriented development environment with Objective-C and Interface Builder. Apps were packaged as clean, self-contained bundles with an accessible installer system. The file system was neatly organized into domains, and the UI was consistent, modern, and supported drag and drop everywhere. In short, it was Unix polished for usability. This also reflects in the out-of-the-box behavior, which skips any lengthy user setup. Instead, a default account, literally named Me, is created automatically. You won't see a login prompt because the account has no password set. Assigning yourself a password using the passwd command or through the graphical user manager is enough to change that. From then on, you'll be greeted with a more traditional login dialog at startup. Whether you use the icon view or the more traditional column view, you'll notice how Nextstep hides away the Unix underlay. Like on macOS today, you don't get to see the traditional Unix directories like /bin or /user. Nextstep organized the desktop applications into directories like NextAdmin, NextApps, NextLibrary, and NextDeveloper. You'll find similarities to modern macOS with the library and application folders on the hard drive. And there's more to it. Whereas on modern macOS the .app extension is hidden, present-day applications are as much organized into so-called application bundles as they were back then on Nextstep. You may find that configure app throws an error when run on a Motorola-based system. That's because the CISC version of Nextstep is a hybrid build for both 68K and Intel CPUs, but this particular app was only intended to run on Intel, which leads to the error. Here you'll also find the previously mentioned user manager, which allows you to manage existing accounts or add new ones. To configure network settings on a Next workstation, you can use the simple network startup app. The machine includes a hybrid 10BASE-T and 10BASE-T connector for 10 megabits Ethernet. Nextstep doesn't support DHCP, so you'll either need a boot P server on the network or configure the IP address manually. One thing to keep in mind, the graphical UI doesn't let you set the DNS server. To define name servers, you need to edit /etc/resolve.conf manually, especially if you plan to use any web browsers. Beneath the Next Apps directory, you'll find things like the Preferences, Mail, Edit and Preview. While Preview undeniably is still the preview app on macOS, minus many bells and whistles, Edit has eventually become TextEdit. Also, Webster still exists today as the dictionary app. And yes, that audio signal heard during this system startup test, also accessible from the control panel, is still found in macOS as well.
Okay, we got it already. Nextstep is macOS.
Well, let's just say Nextstep ultimately became macOS. Nextstep laid the foundation, but macOS evolved far beyond it, with multi-CPU support, a graphics system based on display PDF instead of display PostScript, and modern APIs like Cocoa and Core Animation. It also added sandboxing, hardware acceleration, new security models, and full 64-bit support, none of which existed in Nextstep.
So now you know. This is what we've been up to for the last 3 years.
And let's not forget, that future was nowhere to be seen at that point in time, yet Nextstep couldn't even run Macintosh applications.
But there was Executor.
True, that was a commercially available emulator package, but that's a whole different topic for another time. So if we stay outside the emulator topic, which would give you access to a whole world of Macintosh applications, you may wonder, where do you actually source Nextstep software today? Luckily, there's a surprisingly active link collection over at the Next Computers forum, which also provides access to the Next Files repository. The site fsck.technology hosts a large curated archive as well, and some old user group mirrors are still online. One highlight worth mentioning is the Big Green CD, a redistributable software collection for Nextstep available via the Internet Archive. It's especially recommended since it includes the full set of Lighthouse Office applications. You'll also find these apps on sites like WinWorld PC, Nextfiles and other corners of the vintage software web. Lighthouse Design Limited was a software company that built high-quality productivity apps for Nextstep. They were acquired by Sun Microsystems in 1996 as part of Sun's efforts to compete with Microsoft by offering their own Office applications. While those plans were eventually scrapped, most of the original Nextstep apps from Lighthouse were later released to the public. Ironically, Sun made a second attempt at the Office software market just a few years later when they acquired StarOffice in 1999. When scouting for software, you'll usually find it in tar format. In many cases, those simply contain the familiar .pkg bundles inside, making the installation process straightforward, as seen here for Bash. You'll notice these packages usually follow a common naming convention. For example, a file ending in .b.tar.gc is a binary-only archive, while .bs.tar.gc includes both binaries and source code. Architecture tags like N, I, H and S stand for Next, Intel, HBPA and Spark. So something like appname.nihs.b.tar.gc means a fat binary for all 4 platforms, no source code. Sometimes these packages include command line Unix tools that belong beneath /user or wherever you prefer. I usually go with /user local to keep them separate from the default BSD user land. Installer scripts are rarely included, so you'll typically move the files into place manually like I'm doing here with the gzip and untar utilities. You'll also find archives that contain application bundles. And as already mentioned, these are conceptually the same kind of .app bundles still created today using Apple's Xcode. One thing to watch out for when decompressing, the version of tar that ships with Nextstep doesn't support gzip compression. I first tried using untar only to realize it ignores permission bits, which left me with a broken app bundle that simply refused to start. Inspecting the bundle, which you can do just by opening it in the file browser as a directory, revealed the binary inside and it was missing its executable bits. A quick chmod can fix that, but there may be other permission issues as well. In the end, you're usually better off running gunzip first and then using tar with proper flags to preserve permissions. Once that's sorted, you can move the application to an appropriate directory. I've read that creating a /localapps folder on the root file system is common practice, though you may need to create it yourself if it doesn't exist already. Applications that come with their own installer typically default to installing into /localapps. Installing Unix tools often results in varying degrees of integration. For example, installing Bash won't automatically register it as a valid shell, so if you try to set it for a user account, the system will complain about it being missing from /etc/shells. You'll need to add that entry manually to make it work. Similarly, directories like /user/gnu/bin or /user/local/bin won't bin your path by default. You'll have to update your shell configuration by hand. You may have noticed that I quietly switched to the previous emulator for this segment, mostly because it makes gritty shell details easier to capture. Don't worry, we'll take a proper look at previous in an upcoming episode along with Executor and also Soft PC. And while Nextstep bundled demos like Mondel Pro and the Backspace screensaver, it also included some games along like chess, bonk, a breakout-like game and pool billiards. And if you were around when the groundbreaking Doom was released in 1993, you might be surprised to learn that much of its development happened on NeXT computers running Nextstep. Doom was written mostly in ANSI C, and its software used Nextstep systems for the engine, level editor, build tools and asset pipeline. Level design, texture conversion and internal editing tools all ran on Nextstep. Even the stop-motion sprite processing was part of a NeXT-based digitization workflow. The final game ran on DOS, but much of the engine logic, from lighting algorithms to map partitioning, was built using NeXT hardware. And yes, a native NeXT version of Doom did exist even before the DOS release. It lacked sound at first, but a later version developed by the Omni Group added support for Doom 2 as well. But the Omni Group was also behind something more ambitious, a web browser. That's how OmniWeb was born, one of the first graphical browsers built natively for Nextstep. And yes, we saw it earlier in our Rhapsody exploration. Unlike other Nextstep browsers like NetSurfer and SpiderWoman, OmniWeb supports proxies, which means you can hook it up with ProtoWeb today for a retro-compatible browsing experience. Still, neither of them came first. That honor goes to WorldWideWeb, later renamed Nexus, the original web browser and the first web editor created in 1990 by Tim Berners-Lee on a NeXT machine at CERN. You can still explore it today through a fully emulated version in your browser hosted by CERN's memorial site. They even recovered the earliest surviving binaries and source code from 1991, preserving the true beginning of the web. But it wasn't until 1993 that the web really took off, with NCSA Mosaic developed by Mark Andreessen and Eric Biener. Mosaic was the first browser to display images inline with text, and it inspired a wave of successors, Netscape, Internet Explorer and many others that would define the browser wars of the mid-90s. Ironically, while Mosaic was available for Nextstep, it wasn't a first-class citizen. Mosaic required X11, the standard display system for Unix, which Nextstep didn't include. Instead, Next used its own display server based on display PostScript. To run Mosaic, you had to install a separate X11 environment like Coexist or Cubics Window, both third-party tools that brought X11 compatibility to Next. In my case, I installed Coexist, which is split into three components: the minimal runtime environment, the user binaries and the motif libraries. But you can't just launch Coexist right after installation, it will fail. You first have to initialize the runtime linker, which sets up the required environment path and variables. Once that's done, Coexist launches into a full X11 session, complete with its own window manager and utilities like Xclock. Essentially, you get an entire X11 desktop layered over Nextstep. Not exactly elegant, but good enough to get Mosaic up and running. And if you remember the NetBSD episode on the Macintosh Performer, where X11 took forever to launch, the difference here is night and day. Both machines run at 25 MHz, but the NeXTstation 68040 comes with a built-in FPU, making X11 actually usable. So, we've explored Nextstep from different angles today, its distinctive look and feel, a broad mix of installed applications, patch management and even a few system quirks, including some distant links to the modern macOS we know today. And yet, Nextstep still feels surprisingly modern even 40 years later. Of course, this was only a partial glimpse into what Nextstep had to offer, we've barely scratched the surface of its full ecosystem. How about you? Have you used Nextstep yourself, or maybe remember a favorite app from back in the day? Or was this your first time seeing it in action? Let me know, I'd love to hear your stories. I'm the Vintage Collector, and this was my story for today. Thanks for watching, and don't miss out for part 3 next Sunday.
You'll be able to see a little bit later on today.
Next on the Vintage Collector.
We haven't talked about mass storage.
It may not have been Nexus' greatest success, but it was certainly forward-looking. And while I don't have an X-Cube to demo the original MO setup, I do have a third-party magneto-optical drive, and I'll try to recreate the experience as closely as possible. Prepare for prolonged boot times, experiments with kernel boot arguments, and even an attempt to boot Nextstep from an iOmega Jazz drive.